In elementary school, we've always heard about Isaac Newton, and the apple fell on his head and suddenly he created gravity. But Isaac Newton was very integral in understanding kinematics, physics, and how our world truly operates. And he did that with 3 laws of motion. The first law of motion is that an object in motion will stay in motion until it's acted on by an opposing force. Similarly, an object in rest will stay in rest until it's acted on by an opposing force. The second law of motion states that force is equal to mass times acceleration. And the third law of motion states that every action has an equal or opposite reaction. Now, this is just a lot of words, and it doesn't truly make any sense unless we can see it in live time. So today we're going to be making paper rockets to explain Newton's 3 laws of motions. So, to make your paper rockets, you'll simply need 3 materials. You'll need 1 sheet of paper, 1 straw, about 2 inches of tape, and a pair of scissors. To start out, we're going to take our sheet of paper and fold it hot dog style and make sure you make nice creases. It doesn't have to be exact, and if you can't fold straight lines, that's totally fine. It won't mess up your experiment. Just try to make it hot dog style like this. Once you've made it your hot dog style, you're going to take it like this, fold it hamburger until you have a nice little rectangle. Again, if your creases aren't perfect, it doesn't truly matter. And you'll have something like this. Once you have your rectangle, you're going to unfold that rectangle and just make sure you have 4 little sections. Once you have these sections, you're going to cut along the creases. Now, to do this easiest, I like to hold it hot dog style, and you're just going to cut straight up like this. Then you have 2 rectangles, so you're going to cut each of these, again, just cutting along those creases. Once you have these 4 rectangles, you're going to take your straw. If it's in a wrapper, you can go ahead and just unwrap that. And then you're going to take one of your rectangles that you just cut and hold it against this like it's a nice white surrender flag. You're going to hold it straight to the straw, then you're going to put it on the table and you're going to just roll it towards yourself, making sure that the paper is as tight as you can make it against that straw. It doesn't matter if it's not perfect. Again, it won't really affect your experiment as long as you're doing it as best as you can. Once you roll it all the way out, you're just going to take a small piece of that tape that you got earlier, cut it so it's the right size for you. You could use a lot of tape, you could use a little bit of tape. Again, it won't affect the experiment, and it'll actually just give you more variables. Then you're just going to put the tape around and seal it together. Once you do that, you're going to pinch a hole so then it's nice and closed. Take another piece of that tape and just seal it so it's nice and airtight. Once you do that, if you'd like, you can use these extra 3 sheets of paper and cut out little fins for your rocket to decorate it. But for the purpose of this experiment, we're just going to be using the rocket just like this. Then you're going to take your straw, put your piece of paper back on your straw, and you've got a paper rocket. But how does this relate to Newton's 3 laws of motion? So, the first law of motion that we could discuss was that an object in motion will stay in motion until it's acted on by an opposing force. Now, we also mentioned that it's the same with an object at rest. If I put this piece of paper on the straw, it's at rest. And really, this isn't a paper rocket. This is just a piece of paper on a straw. But if I blow on it, which is exerting force onto it, the paper rocket flies. This proves that an object at rest will stay at rest until it's acted on by an opposing force. And the second law of motion that we discussed was that force is equal to mass times its acceleration. For the purpose of this experiment, I've created an identical rocket, and instead of just 1 slice of paper, I used my extra 3 pieces of paper and made one that had a greater mass than this rocket. Since this rocket has a greater mass, you'll need a greater force to make it go the equal distance. This also means that you'll need a greater force for it to have the same acceleration. To use that, we're going to be using this rocket launcher. This is my one with 1 piece of paper and the lighter mass. If I move this rocket launcher up to 6 centimeters and I put it down, the rocket shoots. Now, this one has a greater mass. If I put this back the same way, same angle, and put it up 6 centimeters, it barely clears the table. This is because force is equal to mass times acceleration, which means that a greater force is needed for an object with a greater mass. You can use this with a straw as well. This is our object with a smaller mass. I went all the way to my computer without a big breath. Now when I do it with my one with a greater mass, I had to use a much bigger breath to make it go the same distance. This is because force is equal to mass times acceleration. Now the third and final one of Newton's laws that we're covering is that every action has an equal and opposite reaction. Now you might be wondering, when I shoot this rocket and an object in motion stays in motion until it's acted on by an opposing force, why doesn't this rocket keep flying? Well, that's because of gravity. Gravity is a constant, which means it's the same across the entire world. In the United States, gravity is negative 9.81 meters per second. And in Antarctica, it's negative 9.81 meters per second. In Australia, it's negative 9.81 meters per second. Across the entire world, gravity is the same. And if you jump up, you'll always be pulled down because of gravity. When your rocket shoots, it will always be pulled down because of gravity. Now, why is this important for Newton's third law? Well, every action has an equal or an opposite reaction. If I were to jump up at exactly 9.81 meters per second, I wouldn't go anywhere. That's because these two forces would cancel out. Negative 9.81 plus 9.81 is going to be 0, which means if these two rockets had the exact same mass, the exact same acceleration, and they flew together, they would hit and fall down perfectly. This is because every action has an equal and opposite reaction. Now, you've learned how to make a cool paper rocket, and you understand Newton's laws just a little bit better.